first? X, Y, or Z? What do you want to solve first? Okay, let's do X. Here we go. Okay. So we're using the right-hand part of the triangle. Okay. We're doing X first. So, what do you want to do? What's the first thing we should do? Label the sides. Now we have a choice because we know this angle and we know this angle. Which angle do you want to use? Because that will change the sides, right? 35? Okay, so if we go stand at 35, this is my opposite, and this is my hypotenuse. What involves opposite and hypotenuse? Sine. So it's sine of 35 equals the opposite, which is 42, over x. Okay, people, tell me what x is, please. What mode must your calculator be in? Degree mode. We'll go to one decimal place. What's the answer? 73.2. Max, we don't know about you. Is it 73.2 or is it 73.7? You're wrong, Max. Okay. We know x. Let's do y now. What are we going to do for y? We only have one angle for y. We'll just use the one angle. Okay. So we label the sides. So this is the opposite. This side right here is the adjacent, and this is the hypotenuse. So we know the adjacent because it's the height, and we're trying to find the hypotenuse. What involves adjacent and hypotenuse? Cosine. So it's cos 45 is the adjacent, which is 42, over y. Frozen again. One decimal place, what do we get? Peoples? 59.4. I would agree with that. Congratulations. Okay, now we need to find Z. What are we going to do for Z? Just tell me in words what you want to do. Sorry? So find this bit, DC, and BD. And once we know those, we add them together and we get Z. Does everybody agree with that? So Z would equal the length of DC plus BD. So let's do DC. We have choices now because we know both sides, right? We found X to be 73.2 feet. So if you know two sides of a right angle triangle, what can you use? The thing. Pythagorean theorem, right? Or we can do trig. It's totally up to you. Okay? Pythagorean. Mm-hmm. So I'm going to leave it up to you because you can do trig if you want. So you can do Pythagorean theorem, and you can do the same for BD. I'm going to freeze it. I'm going to do it. You please do it, and we'll see if we get the same answer. We know Max won't. We have it? What? You're doing both. Like find Z, basically. Ready? Sorry. Okay, here we go. There's your answer. 102. DC is 60. BD is 42. I did trig because I think it's faster. I used tan. But if you do Pythagorean theorem, you should get pretty much the same answer. Might be off by a bit depending on rounding and things like that, but I don't care about that stuff. Exact same. All right. Well, that's good. Any questions about that? Okay. So today we are moving on to non-right angle trigonometry. All right. But before we do that, we have to talk a little bit about notation and how to label a triangle. I don't know if people taught you this. All right. So angles are given capital letters. Okay. So this is angle A, which is right there, angle B, angle C. The sides, so this is an angle. The lowercase letter is the corresponding side. All right. And it's always opposite the angle. So if I say side A, that is right there. It's opposite angle A. Side B is opposite angle B, and it's lowercase. And side C is opposite angle C. Okay? So sides are lowercase, angles are uppercase letters. I'm not going to go into the proof of the sine law. If you want to see it, please come up to me. I will go through it with you, okay, how they actually get the proof of this formula. But this is the sine law, okay? We use it for non-right angle trigonometry. All right angle trigonometry, you can use SOHCAHTOA, all right? Non-right angle, we use sine law, and as you'll see later on, the cosine law. So sine law says the ratio of the side and the sine of its angle is equal to the ratio of all the other sides and the sines of their angle. So basically, A over sine of A is equal to B over sine of B, which is equal to C over sine of C. Okay? Now, you can flip all these to get sine of A over A, sine of B over B, sine of C over C, depending on what you're trying to solve for. Okay? You don't have to memorize these. I will give them to you in both forms. I'll write them on the board. But we're going to use it enough that it shouldn't be too difficult to remember. So there's the proof there. I'm not going to go through that, but if you want me to, just come see me and I will go through it with you. Okay, the whole key about the sine law is you need to know an angle and the measure of its opposite side. I call it an angle side pair. So you need to know A, sine of it. You need to know angle A and side A, or angle B and side B. Okay, if you don't have an angle side pair, you can't use sine law. All right. So here's our triangle. All right. So we have 75 here, 35 here. What do all the angles in a triangle add up to, people? 180. So how do I find angle B? So it's going to be 180 minus 75 minus 35 is 70 degrees. And this little thing here is my angle sine. So I just mean angle B. Okay? So I know this is 70 degrees. All angles in a triangle add up to 70 degrees. I'm sorry? Oh yeah, I said 70, didn't I? All angles in a triangle add up to 180 degrees. If they added up to 70, that'd be really weird. Okay, so now we got angle B. We want to calculate the length of BC. I want to know the length of this side. So, do we have an angle side pair? What pair? C. We know angle C and we know side C, right? What side are we trying to find? When I say BC, what side is that? That's A because it's opposite angle A. So there's a little a, and just for completeness, that's little b. Okay, you have to use the angle side pair. All right? So we have choices here. So we're trying to find A. Whoops. We're trying to find A, right? So if I'm trying to find A, and I have a choice between these two formulas, you want your unknown, or the thing that you're trying to find, in the numerator because it's easy. I mean, it doesn't technically matter. You can manipulate it if you use the other one, but you want your unknown in the numerator. So I want to use this formula with the sides up top. Okay? So we're going to go A over, I'll just write the formula first and then I'll plug it in, over sine of A equals what? We're going to do C over sine of C because we know side C, right? Okay, now we just got to plug stuff in to solve it. So A we don't know, that's what we're trying to find. Angle A is 75 equals side C, which is 12.5, over sine 35. All right, how do I solve for A? Just do it. Yes, we multiply the sine 75 up there. So we go A is equal to sine of 75 degrees times 12.50 divided by sine of 35. Okay, I'm going to do something. You're probably going to laugh, but I've seen people do this. Okay? Do not do this. Oh, well, that sine and that sine cancel out. So it's just 75 times 1250 over 35. Please don't do that. Okay? You cannot cancel functions. All right? If they're both sine 35, yes, you can. All right? Because it's the same thing divided by itself. But if they're different, you cannot. All right. So now we just have to punch this in our calculator. I'm going to let you do that, and we'll see if we all get the same answer. Go to 2 decimal places, please. What did we get? Sorry? 21.05? Boom. Everybody get that? Yeah? Good job, Max. All right. Scrolling down. Use the sine law in the triangle shown to determine the measure of angle ACB. So the first thing you ask, is this a right angle triangle?
No.
No, so we can't use SOHCAHTOA. SOHCAHTOA is out. So now we have to use Sine Law. First of all, we ask ourselves, do we have an angle side pair?
No. Yes.
Right? If you label all the sides, that's A, that's B, and that's C. Now, when they say find angle ACB, what angle are you finding? It's only one you're finding. So when they say find angle ACB, you go like this. A, C, B. You're finding angle C. It's the middle letter. All right? That's not the notation. All right? Because you draw a line A, C, B. The thing that's munched in there is this. Okay? It's always the middle letter. That's the way you can remember it. That's the angle you're trying to find, angle C. Okay, so now we're trying to find an angle. So come on. Oh, there, right there. We want to use this one, right? Because these are the angles. We want to have the angles up at top. So we're going to go sine of C over C is equal to what? Yes, sine of A over A. And then just plug in all your numbers. Oh, hang on. Yes. So what problem did we run into? We don't have anything for C. So what do we have to do first? We got to find one of these things for C. Or actually, we got to find B, right? Because if you know B, what do all the angles in a triangle add up to? 180. So we'll hold that, and I'll do it over here. Find B. So it's the same thing. Sine of B over B is equal to, we're going to use A. Sine of A over A. We know what B is. It's 6. Little b is 6. A is 110. And little a is 9.4. So this is going to be a little different, similar to what we did yesterday. So sine of B is going to be 6 times sine of 110 divided by 9.4. That's going to give us a number, which is 0.5998. Make sure you can get that number. Actually, punch that into your calculator. Make sure you can get 0.5998 or something close to that. .5998. That's sine of B. That's not the angle yet. So how do I find angle B? The sine to the minus 1. So remember, B is going to be sine the minus 1. And that should be 37, 36.8. I'm just going to round to the nearest whole. 37 degrees, if you round to the nearest whole number. Yeah? Okay. So that's 37. Does everybody agree with that? Okay. So do I even need to use the sine law to find angle C? What do I do? Yeah, subtract them from 180. All right. So I don't even need to do that. I can just go angle C is 180 minus 37 minus 110, which spits out 33 degrees. Is that okay? No? Yeah? Yes, Baldwin. Okay. I just want you to do numbers 1 and 2, please. All right, so surveyor measures the baseline PQ to be 440 meters long. He takes measurements of landmark R, P, and Q and finds, okay, angle QPR equals 46. Where am I writing 46? Sorry? Angle P, remember it's always the middle one. So this is 46. Angle PQR is 75. So that's angle Q. What do all the angles in the triangle add up to? 180. So R is going to be 180 minus 75 minus 46, which is 59. So that's 59 degrees. They want to know the perimeter of this triangle. What's the perimeter? What does that mean? Yeah, all the way around. All right. So I need to find side Q and side P. Now it's not A, B, and C, but it's the exact same formula, just different letters. Okay. So what do you want to find first, Q or P? All right, P. So we're going to find side P. So we're going to go, what formula am I going to write out here? Sorry? P over sine of P is equal to what over what? Do we have an angle side pair? R. So that's what I want to use. So 440, or sorry, that should have been little r, over sine of r. There it is. And then plug in everything you know. Sine of P is sine of 46. R is 440. Sine 59. And if you do all that, you should get 369 meters. All right, now we got to find Q. It's the exact same thing. And you can use the R over sine R bit too. So we're going to do Q over sine of Q is equal to R over sine of R. So Q is 496. What? 9. So the perimeter, just add them all up. So 369 plus 496 440 equals 1305. That's your perimeter. Is that okay? All right, we got one last thing to do for sine. Oh, I don't have page 226. That's all right. I can do it off to the side. You guys do, right? It says calculate the area of PQR. Does it have that question? Calculate the area? Okay, so we're going to do that. It doesn't give you anything. It's got the triangle there, though, doesn't it? Okay, so. No, you don't need a protractor. So we got our triangle. I'll redraw it. We know this is 59. We know this is 46. We know this is 75. Okay, what is the formula for... Yeah. What is the formula for area of a triangle? Yes, so area of a triangle is 1/2 the base times the height. We know what the base is, right? They give us that. It's 440. But we need to figure out the height. The height is that. Oh, I had to draw a line straight down. So, how am I going to find the height? What is the good thing about what we just did? We have all the things, and it's a right angle triangle, so we can use SOHCAHTOA, right? Okay. What? Oh, we know the side. What's RQ? What's side? What's this? This is side P. What was P? 369. So this is 369. So we have this little triangle right here. 75. We have the 8. We got to find H, and we have 369. So what sides am I dealing with? What trig function am I dealing with? Yeah. Sine, right? Because this is opposite, and this is the hypotenuse. So it is sine of 75 is equal to the opposite, which is h, the height, over the hypotenuse, which is 369. So 369 times 75 is equal to h, which is 357. So the area is 1/2 the base, which is 440 meters, times the height, which we said is 357 meters. So if you plug all that in, you get 78,540 square meters. All right. Is that okay? Just make sure you have an angle side pair. Sometimes you might have to break it into two separate things if you're trying to find the area or perimeter. Here's what I'd like you to do. Number 4. Number Number 7. Seven to 9. Oh, the humanity. I said number 4 and then pause. My pause was too long. I know.